Okay, so this is Unit 1. I'm calling it Lesson 4. Okay, the lesson is called Angle Measure. Okay, so the lesson is called Angle Measure, so I'm sure you can take a wild guess about what the first definition is. And it's angle. An angle is formed by two rays with the same endpoint. So there's an angle below. You see this is a ray, AB is a ray, AC is a ray. These are two rays. They have the same endpoint A, so that is called an angle. Okay. Now the next sentence says the rays are the sides, so that's a side. That's a side. The endpoint is called the vertex. And angles that have the same measure. Think back to the segments. We did segments that have the same length or the same measure are called congruent segments. And angles that have the same measure are called congruent angles. Congruent angles. Okay. Now we have an angle drawn right here. Before I move on, let's talk about naming this angle. Okay. There are four ways to name this angle. There's four ways to name this angle. One way to name the angle is you're going to use three letters. You're going to say angle BAC. A is the vertex, as noted above. Okay? The vertex has to be in the center. So you could say angle BAC. Okay, the vertex has to be in the center. So angle BAC is not the same as ABC or ACB. Okay, the vertex, in this case A, has to be in the middle. So that's one way, angle BAC. Or you could go the other way and say angle CAB. Another way to name that angle is with just the vertex. So you could call that just angle A. But if you have a big diagram with a lot of angles labeled, that's not how you want to name it if you have a big diagram, because it might be confusing what angle you're talking about. I'll mention that on the next page more. Okay, but if you have just like a single angle drawn, you can just name it angle A. But if there's a big diagram, and it can get confusing if you just use one letter, so the top two ways are better. And the other way to name that angle is with the number on the inside, so you can name that angle 1. Okay. This is just a recap of what we just talked about. So it says an angle is formed by two non-collinear rays that have the same endpoint. There's a diagram here, and it shows you how to name it. Again, four ways. So you can name it just for that angle A. You can name it BAC. You can name it CAB, or you can name it with the number in the middle. So angle 4 in this case. Okay, and points. That's the vertex. That's a side. That's a side. It's just a recap of what's above. Okay. Last thing on the first page. An angle divides a plane into three distinct parts. So if you have an angle right here, okay, points A, D, and E, A, D, and E, those lie on the angle. Okay, this is our angle. A, D, and E lie on the angle. Points C and B, those are on the interior of the angle. So in this case, points C and B lie in the interior of the angle. They're inside the angle. Like an interior decorator decorates the inside of your house. B and C lie inside the angle. That's called the interior of the angle. And points F and G in this case lie outside the angle. That's called the exterior. Okay. Move on to the next page. This lesson has 3 pages. This is what I mentioned earlier, just real quick. If you were to name, suppose you want to talk about this angle right here. You don't want to call that angle right there angle W, because that'd be really confusing if you're talking about that. Like if you just say angle W, I don't know what angle you're talking about. So this is an example where we have a big diagram where it might not be good to name an angle with just one letter. Okay. So anyway, let's go to the actual example now. Example 1A, name all the angles that have W as a vertex. Okay, so one example, the angle 1 has angle W as a vertex. Angle 1 has angle W as a vertex. So does angle 2. Angle 2 has W as a vertex. So does angle 3. Angle 3 has W as a vertex. Okay. How about if I talked about this big angle right there that kind of combines angle 1 and angle 3? That has angle W as a vertex. So I'm going to name that angle XWY. And there's one more. How about if you combine angles 2 and 3? That has W as a vertex. So I'll call that angle VWZ. And that looks like all of them. Part B, name the sides of angle 1. So this is angle 1 right here. Okay. So the sides are ray WX and ray WZ. So WX and WZ. Part C, state another name for angle WYZ. WYZ. Okay, you got to be careful. If you want, you can color in the diagram. WYZ. You can color in if you want. And you should see that angle 4 is another way to name that. I can also name it angle ZYW. I can do the opposite. And I can also name it by just the vertex, angle Y. Again, that's probably not the best way to name it, especially when you have such a big diagram. I mean, this would be preferred, or this, or this. Those are all the different ways to name angle WYZ. Okay, so we have some different types of angles. Some of this you might know already. Acute angles are angles that have a measure of greater than 0 degrees and less than 90 degrees. Okay. Right angles measure exactly 90 degrees. They are going to be denoted with that symbol in diagrams. Obtuse angles measure greater than 90 and less than 180. And straight angles measure 180 degrees, and they are a line. Okay. Now, we can't hand out protractors this year, but let's do the next best thing. Let's try these examples. Find the measure of each angle and then classify it as acute, right, or obtuse. So I gave no straight ones on this. There's no straight angles in here. Let's start with angle BOA. Now, whenever you want to say an angle has a certain measure, you write it like this. You're going to put a little m, measure of angle BOA equals. Okay? So if you look at angle BOA, it's right here. You'll see it goes through two numbers. It goes through 40 and 140. So you're going to have to think, which one is it? Is it 40 or is it 140? And the way to think about that is to see ahead of time, is it less than 90 or is it greater than 90? Angle BOA is less than 90 degrees, so it's going to be 40, not 140. So measure of angle BOA equals 40 degrees. That's how you write it. Little m, angle BOA equals 40 degrees. Classify it. This is acute. Part B, the measure of angle DOB. DOB. First things first, this angle is bigger than 90. Okay? It does not start at 0, it starts at 15. See, it's between 10 and 20. It goes from 15 all the way up to 140. Okay? It goes from 15 all the way up to 140. So you're going to subtract those two. 140 minus 15. You should get 125. And that is obtuse. The other way to think about it is if you want to go from here, you can do 180 minus, let's see, DOB. You could do 180 minus 15. And then measure from here to here. If you want to do it like that, I think the way I did it was easiest. I just went from here to here, 140 minus 15 is 125. I think that's good. I would just do it like that. There's more than one way to do these. I think that's best. Okay, the last one, the measure of angle EOC. EOC. Okay, well, first of all, it's bigger than 90, so you should know that ahead of time. And if you look at the two numbers it goes through, it looks like it's going through 75 and 105. So again, you want the one that's bigger than 90, because you can tell ahead of time it's bigger than 90. So the answer is 105, which is obtuse. Okay, on to the last page. This is just a recap from the first page as well. So just as segments that have the same measure are congruent, angles that have the same measure are congruent. I mentioned that on the first page. And this is the symbol for that. So if you look at the diagram, this angle right here is 25 degrees. This angle right here is 25 degrees. So it means that their measures are equal, which means that the two angles are congruent, okay? And those will be labeled in diagrams if they're congruent with arcs. So for example, this angle has one arc on it, and this angle also has one arc on it. That means that they're congruent, okay? So if this angle had two arcs, and this angle had two arcs, that means that they're congruent. Okay, if this angle was labeled with 3 arcs, and this angle is also labeled at 3 arcs, that means that they're congruent, and so on. Okay. So let's try number 3. Okay. It tells you in the diagram below, angle ABC is congruent to angle DBF. So this is angle ABC. I'll put one arc on it, just for the heck of it. And this is angle DBF. I'll put one arc on it, just for the heck of it. So those two angles are congruent. So I'm just going to write that over here. You're also given that. That's the symbol for congruence. Okay. You can see it right there as well. Since the two angles are congruent, it means that their measures are equal. So this is important for notation. When you want to say two angles are congruent, that's the congruent symbol. This is how you write it. Just angle ABC is congruent to angle DBF. If you want to say the measures of two angles, you have to put measure of angle ABC, and you have to put equals measure of angle DBF. That's just notation. So let's substitute 6x plus 2 equals 8x minus 14. Now the question is find the two angle measures. So to do that, you have to find x first. So I'll bring all the x's on one side, subtract 8x on each side. Then subtract 2 on each side. Divided by -2, you get x equals 8. That is not the final answer. You have to find the measurement of these two angles. Okay? So look how I'm going to write this. I'm going to say the measure of angle ABC equals 6x plus 2. And you know x is 8, so substitute 8 in for x. The measure of angle ABC equals 6 times 8 plus 2. So 48 plus 2 equals 50. The measure of angle ABC equals 50. Again, look how I'm writing it. The notation matters. Measure of angle ABC equals 50 degrees, just like we did in example 2. So the question said find the measurement of angle ABC and find the measurement of angle DBF. You should know they should be the same because you're told that. So you should know that the measure of angle DBF equals 50. But that's kind of risky to just put that right now. I would just do out the work just to check yourself. So let's do out the work. The measure of angle DBF equals 8x minus 14. So substitute 8 times x with 8 times 8. Eight times 8 is 64. (64 minus 14 is 50. Again, look how I'm writing the answer. Measure, little m, angle DBF equals 50 degrees. Notation is very important in geometry. And perfect, they're the same. They should be the same. You were told they were congruent, so you were told that the measures were equal in the problem. And by doing them both out, that helps you check yourself. So I know I got them both right. What are the odds of me making a mistake in both of them and getting 50 for both? What are the odds? Very small. So by doing that, I know it's correct. Okay. And one more definition. If you remember back to lesson 3, I told you a segment bisector is something that cuts a segment into two congruent halves. Okay. This is called an angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. So if you look at this big angle, RPS, that's cut up into two congruent angles because that has one arc and that has one arc. And it's cut up by QP or PQ. So ray PQ is an angle bisector. Of angle RPS. Because that ray PQ, cuts angle RPS into two congruent angles. Okay? So that is the end to this lesson. And again, this lesson was called angle measure.